In the last video, we covered the different forms of partial fraction decomposition. We talked about the different ways in which a rational expression can be broken apart depending upon the factors of the denominator of that particular rational expression. In this video, we're going to talk about the remaining steps for partial fraction decomposition, how we are going to solve for our constants that we generated and write our final answer. Now, here are all the steps for partial fraction decomposition. Step number 1, divide if improper. That means if the degree of the numerator is greater than or equal to the degree of the denominator, use long division to divide your polynomials. After that, we factor the denominator completely. That's going to tell us the form of our partial fraction decomposition. In step number 3, we can begin to decompose. Separate the rational expression into the sum of multiple fractions. As we talked about before, the number of fractions will equal the total number of factors, and the form of the decomposition will depend on whether the factors are distinct linear, repeated linear, or of the quadratic type. After we write the form of the partial fraction decomposition, we are going to multiply everything that we see by the least common denominator. Multiply our entire equation by the least common denominator. This is going to allow us to get rid of all of the fractions and set up an equation that's going to allow us to solve for our constants and write our final answer. That's what we're going to talk about here. So let's go through and cover a couple examples. Write the partial fraction decomposition of the rational expression. We have 7 divided by x squared minus 14x. Well, the degree of the numerator is less than the degree of the denominator. Therefore, we do not need to divide. We can move on to step 2, where we factor our denominator. We can begin by factoring out a greatest common factor of x. This leaves us with 7 divided by x times x minus 14. Notice that we have 2 factors in the denominator. Because we have 2 factors, that is going to break apart into 2 fractions. And because they are both distinct linear factors, we're going to have a constant divided by our first factor plus another constant divided by our second factor. There we have the form of our partial fraction decomposition. Our original expression is going to break apart into some constant a divided by x plus some constant b divided by x minus 14. To finish off the problem, we have to solve for these constants. And to do so, we want to get rid of all of the fractions by multiplying by our least common denominator. The least common denominator is x times x minus 14. And one little tip, the least common denominator will always be the denominator of your original fraction. Okay, so we multiply by x times x minus 14, this entire equation. And in doing so, hopefully you recognize the x times the x minus 14 and this x times x minus 14 in the denominator are going to cancel out, leaving us with 7 on the left-hand side of the equation. When I multiply a over x times x minus 14, the x's are going to cancel out, leaving me with a times x minus 14. And when I multiply b over x minus 14 times x minus 14, the x minus 14s are going to cancel, leaving me with b times x. So we have 7 is equal to a times the quantity x minus 14 plus b times x. Now that we've gotten rid of the fractions, we want to expand our equation. Let's do out our algebra and distribute. So we expand the equation by multiplying our a through. This gives us 7 is equal to a times x minus 14a plus bx. After that, we want to group any terms that have the same powers of x and group all of our constants, anything that's just going to be a number. Notice ax here and bx here. We want to group those 2 terms together. This minus 14a has no variable x associated with it. Therefore, that's going to just be a constant. We can group that on the end. 7 is equal to ax plus bx minus 14a. Now we see that x is common between these first 2 terms, and we can factor it out, leaving us with 7 is equal to a plus b, the quantity a plus b times x, minus 14a. Now, this is not our final answer, but it's an equation that is going to allow us to solve for our constants. Here's why. An equation. An equal sign. This means that the left-hand side is equal to the right-hand side. Well, take a look at the left-hand side of this equation. How many x's are on the left-hand side of the equation? There's actually 0 x's on the left-hand side. So in order for this equation to be true, that means there has to be 0 x's on the right-hand side. What does that mean? The quantity a plus b must be equal to 0. Similarly, the constant, the number on the left-hand side, is 7. This minus 14a is going to generate the constant on the right-hand side. This quantity, negative 14a, must be equal to 7 in order for the equation to be true. Well, we have a plus b is equal to 0, and negative 14a is equal to 7. What did we just do? We generated a system of equations. And we can solve the system of equations to solve for our constants a and b. Notice, taking this second equation and dividing by negative 14, we get a is equal to negative 1/2. We can then back substitute that into our first equation here. Negative 1/2 plus b is equal to 0, which means that b is equal to 1/2. Once we solve for our constants a and b, we can back substitute them into the form of our partial fraction decomposition. So, to write our answer, always begin by writing out the original fraction. We had 7 over x squared minus 14x is equal to, and notice what did it break down into? A over x, so we plug in negative 1/2 for a, divided by x, plus b over x minus 14. Well, b was positive 1/2, so I have positive 1/2 over x minus 14. And finally, to get our final answer, all we need to do is simplify these complex fractions. Well, I've got this fraction in the numerator. That means that this 2 is going to be brought down to the denominator. Same thing with this 2 in this numerator of our second fraction, going to be brought down to the denominator. Simplifying complex fractions gives us 7 over x squared minus 14 is equal to negative 1 over 2x plus 1 over 2 times the quantity x minus 14. All right, that's a perfectly acceptable final answer. If you're really good, you might also consider bringing this term to the front, giving us a final answer of 7 over x squared minus 14x is equal to 1 over 2 times x minus 14 minus 1 over 2x. Again, same answer. Mathematicians, we like to put positive numbers first. It just saves us from writing one more sign and makes it look a little bit neater. Let's try another one. Write the partial fraction decomposition of the rational expression 2x minus 3 divided by x squared minus 2x plus 1. Now, the degree of the numerator is less than the degree of the denominator. Therefore, we do not need to divide, and we can skip to step 2, where we factor the denominator. In this case, the denominator factors into x minus 1 squared. Remember, x minus 1 squared, that is the equivalent of x minus 1 times x minus 1. So we have two factors repeated. Okay, this is an example of repeated linear factors. And whenever you have repeated linear factors, you need to have one fraction for each time that factor is repeated. And because they're linear, the numerator is always going to be a constant. This means this is going to decompose into a over x minus 1 plus b over x minus 1 squared. Now we have the form of our partial fraction decomposition. To solve for our constants a and b, we begin by multiplying by the least common denominator. Again, the least common denominator is the denominator of your original fraction that you are decomposing. When we do this, we get rid of all of our fractions. Notice that when I multiply x minus 1 squared times the left-hand side of the equation, the x minus 1 squareds are going to cancel, leaving us with 2x minus 3 is equal to a times, notice one of our x minus 1s will cancel, a times x minus 1 remains, plus b, and both of the x minus 1 squareds are going to cancel, leaving us with just plus b. 2x minus 3 is equal to a times the quantity x minus 1 plus b. Again, multiplying by that least common denominator gets rid of all of our fractions. Now we want to expand our expression and collect our like terms? Well, if I multiply this a through, we get 2x minus 3 equals ax minus a plus b. Now, it actually ended up grouping our like terms together for us. This is the only term that has an x associated with it. Negative a plus b, these are the only terms that don't have a variable x associated with it, which means they are going to generate the constant. Well, as we said before, this equal sign means that the left-hand side is the same as the right-hand side. On the left-hand side, how many x's are there? There are 2 times x, 2 x's. That means, in order for the equation to be true, there must be 2 x's on the right-hand side of the equation. That means a, the coefficient in front of this x, must be equal to 2. Similarly, the constant on the left-hand side of the equation is negative 3. Well, because these two terms don't have any variable x associated with it, the combination of them is going to create the constant, meaning negative a plus b has to equal negative 3. And what did we just generate? A system of equations. And the good news is we actually already have one of our variables, one of our constants solved for us. A is equal to 2. Okay? So we can back substitute that into our second equation, giving us negative 2 plus b is equal to negative 3. Adding 2 to both sides of the equation gives us b is equal to negative 1. Now that we have solved for a and we have solved for b, we can back substitute them into the form of our partial fraction decomposition. To write our final answer, 2x minus 3 divided by x squared minus 2x plus 1. Now again, that's just the original fraction, okay? And what did it break down into? What does it equal? A, which is 2 divided by x minus 1, a over x minus 1, plus b, which is negative 1, over x minus 1 quantity squared. And to get our final answer, we don't want to leave adding negatives, so we can take this negative 1 out from the numerator and put a negative in front. Just rewrite this addition as subtraction. 2x minus 3 divided by x squared minus 2x plus 1 is equal to 2 over x minus 1 over the quantity x minus 1 squared. And if we wanted to check our work, we could certainly find a common denominator between these two fractions, subtract them, and that would bring us back to what we started